Okay, good evening everyone. Myself Milan Patil and we are going to start with a new chapter from standard 8th class, that is chapter 13, sound. Let's see what are we going to learn in this lesson. We are going to define what is sound. We are going to list the different sources of sound. We are going to understand how the sound is produced, that is production of sound, working of human voice box, propagation of sound, characteristics of sound wave, human ear, structure and function, audible and inaudible sound, and finally we are going to learn about what is noise pollution, what are the causes, effects and prevention. We communicate with each other by talking and listening, isn't it? You know that when we speak, we make sound, and when we listen, then we hear the sound. So there are many things around us that produce a sound. A sound that produced at one place takes some time to reach another place. So in this chapter, we are going to understand how the sound is produced by the different object, what are the characteristics of this sound and the different methods of propagation of this sound wave, the characteristics. Let's begin with understanding what is sound. What is sound? Sound is a form of energy that causes sensation of hearing in our ear. Let me repeat for you. A sound is nothing but it is a type of energy. We know that there are different types of energy like light energy, wind energy, nuclear energy, solar energy. All these are different types or forms of energy. So sound is also a type of energy that causes sensation of hearing in our ear. Okay, to know more about this, so simply we can define anything we hear, going to call it as sound. Vehicles moving on the road create sound waves, isn't it? So any vehicle you see moving on a road, it is going to create or produce sound. Ceiling fan also produce sound, whether it is on whether while it is off also. During both the time it create or produce sound. So what is a source of sound? So how we will define a source? A object due to which the sound is produced, we are going to call that object as a source of sound. For example, if I am talking here, I will be the producer of the sound. Okay, the sources of the sound can be all those objects around us which are producing the sound. For example, we have the cell phone or the mobile phone. If it's ringing, that means it's a sound producing object. Or vehicles moving on the road, or different types of vehicles which are there also produces sound. So that can be a source of sound. The different musical instruments which are being used, which are producing a sound, that can be a source of sound. Animals around us, which when they communicate with one another, they also produce sound. Okay, so a source can be any object, a living or a non-living object which produce a sound, and we going to call that object as a source of sound. Can you name some more examples in the chat box? Any more examples of sources of sound that you hear in your surrounding and that can be act as a source of sound? Now let us understand what causes sound. Okay, how the sound is caused. You must have seen your school bell. Nowadays, when now it is a pandemic situation and now you all are not coming in the school, so now you hardly get to hear the sound of the school bell. But when you were coming in the school during those time, you have seen a school bell, or you must have heard a school bell that is being rung at every period. Okay, after the end of each period you hear a school bell. Okay, what is this school bell is made up of? It is made up of metal, isn't it? Okay, and how the sound is produced in that school bell? So there is a metal gong and there is a hammer attached near the school bell. So when this hammer strikes that metal gong, it produces or causes the sound. When the hammer strikes the metal gong, that is, the metal gong is vibrating. So from this example, we get some little idea how the sound is produced. Sound can be produced or cause of the sound is vibration. Let me give you another example. What you can see, this device which you can see in this picture is called tuning fork. What is it called? A tuning fork. When you strike this, it's basically a device which is made up of metal. When you strike the tuning fork against some hard object, you see these plates of the tuning forks are moving back and forth, isn't it? They are moving here and there. Okay, these metal plates are moving from left side to the right side. Okay, that means they are vibrating. So what causes sound? And what do you observe in this tuning fork? That I already asked you, that these plates are vibrating. Okay, these plates are vibrating. So what do you mean by the term vibration? Okay, or how do you define a vibration? Okay, this vibration is nothing but we see this tuning fork plates are moving back and forth. They are moving from left side to the right side, okay, and back and forth again and again. So that means this tuning fork is under the process of vibration, that is vibrate, and because it vibrate, you hear a sound. If you take this tuning fork near your ear, you will hear a faintest sound in the ear. Okay, right now it is not possible for me to show this activity, demonstrating the activity. But if you take the tuning fork near your ear, you will definitely hear some sound. That means the sound is produced due to vibration. How the sound is caused? So now you know exact reason of how the sound is produced. What is the, you may get a question for exam, how the sound is produced or what causes sound. So sound is caused due to vibration. And what is vibration? Vibration is nothing but back and forth movement. Okay, back and forth movement of an object is termed as vibration. So sound are made when object vibrate. Whenever any object vibrate, it produces or it causes sound. Another activity which you can definitely do at your home. You take a compass box, okay, and what are you going to do to that compass box? You insert a rubber band, stretch a rubber band and put it aside like this as shown in this picture. And you can raise the rubber band by inserting two pencils at the end. And now you can gently pull the rubber band from one side. What do you will notice after some time that this rubber band will start vibrating. You can do this activity at home today. Once you finish the class, you can try out this activity. You will notice that a rubber band will started moving from left side to the right side, and as it is moving, it is causing or it is producing sound. Okay, so sound is generated or produced due to vibration. Another activity you can try today, okay, this one is a drum. Okay, when we strike the drum, okay, if you have a drum at home, you can do this activity. Okay, a playing drum, you just put some mustard seeds on the stretch membrane of the drum. Okay, what are you going to put? We are going to put mustard seed, and once you strike the drum, that means the stretch membrane of the drum is vibrating and it is producing sound, right? So how do you can prove that vibration is being set in that stretch membrane of the drum? When you put mustard seed over that stretch membrane of the drum, you will notice that mustard seed will start popping out. It will start dancing. Okay, this activity gives clear indication that sound is produced due to vibration. Okay, sound is caused due to vibration. And what is vibration? Vibration is nothing but back and forth movement of an object. So So what is vibration? Back and forth movement of an object is termed as vibration. So as I have already defined a vibration, let us put it here. A rapid to and fro movement or up and down movement or back and forth movement from a main position is termed as vibration. So sound is produced because of this vibration. So when we hit the drum, what happens to the drum? The membrane start vibrating and it produces a sound. Similarly, let us take another musical instrument. What is this musical instrument? What's the name of this musical instrument? Yes, this is called guitar. Okay, guitar. Which is part of the guitar is is vibrating there, and which is going to produce sound. In guitar, we have the strings. Okay, strings like this. When you pull those strings, it vibrates and it moves up and down or back and forth, and it produces sound. Okay, it produces sound. So from all this activity, what do you conclude? That sound is produced by vibration. Many of you must be knowing to play different musical instrument. Can you name some musical instrument which produce sound by vibration? You can use the chat box to give your answer. Okay, so what vibrates so that the following makes sound? Okay, you are going to identify now. Okay, from this activity we have the first one, guitar. So which part of the guitar will vibrate to produce sound? In case of guitar, in guitar we know that there is a strings. Okay, string system. The strings, when you pull those strings, it vibrate. In drum, which part is vibrating that produces sound? In drum we have the stretch membrane. Okay, a stretch membrane. This strings, this stretch membrane which is there, when you strike it, it vibrates and it will produce sound. Okay, how do you know how you get sound from the speaker? There is again a stretch membrane here. Okay, this stretch membrane vibrates and it produces sound. Do you know how human being produces sound? How are we producing sound? Do you know the answer behind what is the cause of sound production in human being? In human being there are vocal cords. Okay, so we are going to understand how the sound is produced by human beings in little more detail right now. Okay, so I have already given you example that violin or guitar string is there, in drum that stretch membrane is there, in the human box there is a voice box, okay, which is called a larynx. We are going to learn about it, that causes or produces sound. And in the speaker, this conical shape which is there, which have the membrane shape, which vibrate and produces sound. There are these, in this picture you can see so many musical instruments. Can you name the part which produces sound in this musical instrument? I will just number them so that you can answer very comfortably in the chat box. Okay, these are different musical instruments and you are going to tell me how these musical instruments produce sound. Okay, which part of this musical instrument produces sound? Well, let us take the first one. Okay, that's the sitar. Okay, how it produces sound? It's similar like a guitar or a violin. There is a stretch strings. So the strings which are there, when you pull them, they vibrate and they will produce sound. What about tabla, the second one? How tabla is going to? Yes, very nice. Chinmay is giving answer about tabla. It's a stretch membrane. Very good. Okay, the stretch membrane in the tabla is going to produce or cause sound. Okay, when it vibrates. What about the third one, shehnai? How shehnai is going to produce sound? Okay, shehnai, you must have heard people playing shehnai during the wedding or some religious festivals. Okay, how it produces sound? You have to blow air into it, isn't it? So when you blow air into this, the air moves through this, and the Shehnai Vadak or the Shehnai player, there can you see this air holes here for the movement of air to come out. So he is going to put fingers on those holes, and this air molecule vibrate and it produces beautiful sound in the Shehnai. Similarly, this instrument also there are strings attached. This strings causes the sound production in this musical instrument. The dholak, again like a tabla, both are similar, stretch membrane. Okay, what about flute? How sound is produced going to cause in flute? You know that? Yes, flute and Shehnai is similar. So when you blow air, that is going to vibrate and it's going to produce sound. What about violin? What is there in the violin? In the violin, we know that strings are there. So when you pull those strings, or when you move over that attached handle over the strings vibrate and it produces sound. Similarly, drum, it's the stretch membrane. Whereas this musical instrument, okay, that's the baja, or it is also called, this one is producing generating sound when you blow air into it. So when you blow air into it, it produces sound. Okay, these are the different musical instruments. So in this table you can see the names of different musical instrument and how it produces sound. So veena, a stretch string; sitar, a stretch string; violin, again a stretch string; tabla, stretch membrane; mridangam, okay, that is also the dholak type, okay, which look like a dholak, a stretch membrane; drum, again a stretch membrane; shehnai, flute and mouth organ, which were there in the previous slide, all that is air column. When you blow air into it, it produces sound. These are the pictures, and that's the table where you have this musical instrument and their vibrating parts. Okay, now some musical instrument produce sound when you beat them or when you hit them with some hard object. For example, a bell, okay, a bell that you either you see in the school or in the temple or religious places or churches. How it produces sound? It's made up of metal. When you strike it with a hard thing, it will vibrate and it is going to produce sound. Okay, then there's a ghatam. Okay, similar to ghatam, we have one musical instrument which we play in Goa during Ganesh Chaturthi, but we don't play, the ghatam is being played on the outer side of this. It's made up of adanware, okay, it's made up of mud, but we have the similar musical instrument which we use during the Ganesh festival. What is it called? What is the name of that musical instrument? But there is a stretch membrane attached to that musical instrument which is going to cause sound. Do you know what's the musical instrument I am talking about? Yes, it is called ghumat. I hope you know what is ghumat. Yes, this famous musical instrument, we use it during the Ganesh festival. Very nice. Ganesh has already given that answer. Okay, when we have manjira, okay, this tar, what we call in Marathi, that is when you strike against one another, it produces sound. Jal tarang, you know what is jal tarang? You have to take a container like this, or different sizes container in increasing order or either decreasing order, and you put the water in either increasing order, decreasing order, and when you strike them, this water in this container cap, they vibrate and it produce a melodious sound. Okay, that's how the different musical instrument work. So different musical instrument that are being used by the people to play around are all based on this production of sound. So what is the cause of sound? How the sound is produced in these different musical instruments? So what we have noted, that sound is produced due to vibration. So either the stretch membrane will be there, either the stretch string will be there, or sometimes we strike that musical instrument to produce a sound, or we blow air into it to produce the sound in that particular musical instrument. Let us see how the sound is produced by human being. Okay, how sound is being able to produce by ourselves. We communicate with one another by talking, isn't it? So I'm talking here and I'm able to communicate with you because the sound is being produced by my vocal cord, and because of that my voice box which is there, which is producing, which is vibrating those things, and it is producing sound. So you are able to hear me right now. That is all because of the sound that is being produced by my one part which is there in my body, which is called a voice box. Okay, and because of which communication is right now possible. Okay, so let us see how first the sound is produced. How the sound, we know that when you I have already told you what is the cause of sound. Sound is produced because of vibration. Let us see actually what you mean by that. Okay, there are air around the source. Suppose there is a bell. Okay, suppose this bell is there. That's a musical instrument. When you hit it, when you strike this musical instrument, what happens when you strike that metal bell? It's generating or producing sound. Now let's see in detail what exactly happening. There is air around that source. So that let us right now consider this as a source of sound. Okay, so that now when I strike it, it will produce sound. So air around it will also begin to vibrate. Okay, there are air molecules. You can see this animation. In this animation, can you see these molecules are moving up and down? Okay, so when I strike that musical instrument, it is right now it is the source of the sound. So what is happening to that musical instrument? It is generating sound, it is producing sound. So when it produces sound, the air around it also start vibrating. So that is a layer of air which is the closer molecule, which is very close to this source of sound, will vibrate more, and this vibration is passed on to the next molecule. The next molecule hit the first one, and the vibration is passed on to the next one, and similarly the molecules around that source of sound will all start vibrating, all start colliding with one another, and the vibration is passed on from one molecule to the other molecule, and that's how the sound is being heard from the place of source to the listener. Suppose there is a person over here. Okay, so this listener, how is able to hear that sound? Because the sound vibration is traveling through the air molecule. If air molecule were not there, will you able to hear that sound which is being produced by that source of sound? Definitely no. We are going to understand in the later part of the lesson that how the sound travel from one region to another region. Okay, so what is the cause of the sound? Vibration. Now what exactly happened? So air molecule around the source, I told you, they start vibrating, and there is a layer of air which is closer to the source, which they will start vibrating first, and the vibration pass on from one to the other. How the vibration is moving? It is moving in form of wave. Have you seen water waves? Have you seen waves in water? You must have visited beach area. You must have definitely seen the wave near the beach side, okay, or the water wave or water ripple. So you know that water moves like this up and down. So the sound also moves, the vibration that is being produced by the source moves like this from one place to another in form of waves, and it spread in all direction, not only one direction, it starts spreading in all direction. Therefore when the bell is being struck, you know that you can hear the sound of the bell up to certain distance. Yes or no? That is because the sound is traveling from that source to the listener's ear in form of wave, and because of that we are able to hear that sound. So now as you know, so what is the exact cause of sound production? It is vibration. So this vibration get transferred from one particle to the other. Can see this in this animation, you will able to see it very clearly. When suppose the source is there which is generating a sound, okay, right now suppose there is a source which is generating a sound, it's going to, when you hit it, it vibrate because air molecules are closer to this source, they get collide to this source which is vibrating, and the vibration is passed on to this first molecule. The first molecule hit the next one, it is passing the vibration to the next one. So when the third molecule hit the fourth one, it is passing the vibration to the next one, and in this way the vibration is being passed from one molecule to the other one, from one particle to the other particle. And how do sound travel? I have already told you, sound travel, this vibration travel in this pattern like a wave, and that's called a sound wave. What we call such thing? So sound move like a wave. Okay, just like you have seen water wave, similarly sound move like this. So if there are no air molecule, if there was no air, do you think the sound will travel from the source to the listener? Suppose there is a listener over here. Do you think will the sound, if there were no air molecule, sound will able to travel from that source to the listener? Definitely no, right? So air molecules plays a very important role in propagation, in transfer of this sound wave to the listener. So how the sound travel? In form of sound wave. And how it able to travel from the source to the listener? Because of this air molecule. So therefore the sound needs something to travel, and what is that? It is called medium. Okay, sound need medium to travel. So here air act as a medium of traveling of sound. There can be medium can be of three types. Okay, one can be solid medium, other can be liquid medium, the third one it can be a gas or a air molecule, which can be a medium. So the medium of sound traveling can be three things: solid, liquid or gas. Sound do not travel in vacuum. What do you mean by the term vacuum? Vacuum is a place where there is no medium at all. Okay, there is no medium at all. There is no solid molecule, there is no liquid, there is no gas molecule, there is nothing in that. That's called a vacuum. Okay, there sound cannot travel. Okay, also, and you go outside the earth atmosphere, we know that there is no air, there is no nothing in the space, so there is communication between the astronaut is not possible. The sound, there is no medium. Even if you talk, there is nothing, that sound is going to travel from you to the next astronaut. Okay, therefore astronaut also cannot communicate by normally talking over there. There is a special thing that they use over there, so that they will communicate with one another. Okay, so we know that how the sound is traveling from one place to another in form of wave. And what do we call it as? We call it as a sound wave. As I already told you, we call it as a sound wave. Now there can be two types of sound wave. How many types of sound waves? Two types. So depending on how the air molecule moving, okay, the pattern, how it create a pattern, there can be two different types of sound wave that is can be generated. One is called a transverse wave, other one is called a longitudinal wave. So how many types of waves are there? Transverse wave and longitudinal. Let us understand what is the meaning of transverse wave, what is the meaning of longitudinal wave in detail. Okay, now look at the animation. Okay, look at the animation down. Okay, what you can see, the molecules are moving up and down, and it is generating a pattern like this, isn't it? So what is happening to the molecule in a transverse wave? The molecules move up and down above the mean position. Okay, that's called a transverse wave. So in a transverse wave, particle vibrate up and down. They are going to move up and down. So as you can see in this animation, the movement of particles in case of transverse wave is up and down in the mean mean position, and that's called a transverse wave. Let us now understand what's the meaning of longitudinal wave. Wave particle vibrate back and forth in a longitudinal wave. For example, what you can see, some molecules are coming closer, some are moving far away, isn't it? So the pattern is like this. Okay, like this. Some are very closer, some are very far. Then again some are very closer, some are very far. The vibration is travel like this. Okay, that's called a longitudinal wave. Longitudinal wave is sideways. Okay, to left side to the right side. Okay, so particles are moving back and forth. In a long transverse wave, how they were moving? In transverse wave, how they were moving? In a transverse wave, they were moving up and down. In longitudinal wave, what is the pattern that is being followed now? Molecules are moving back and forth. Therefore, you will see that some molecules are very close by. Yes, some are very close to one another. Some regions you will find very much less molecules, scattered molecules. So, for example, observe this. Some regions you will find very less molecules. Some region you will find very more molecules. So, molecules are coming back and forth, back and forth. So, that movement is called longitudinal wave. So, how many types of waves we have learned now? Right now, how many types of wave? There are two types of wave: transverse wave and longitudinal wave. Let us now try to understand how we are able to produce sound, or how human being is able to produce sound. That's very interesting, right? Human body able to produce sound because of something which is there in the sound. So human sound is the sound which we hear the most, isn't it? And since all the sound are produced by some kind of vibration, so there must be something in our body which must be vibrating and it is producing sound. Right now you can touch your neck region and try to produce a sound. You will feel the vibration. You can do the activity right now with me. What are you going to do? You are going to produce some sound and you are going to keep your finger on the neck region. What do you notice now? You can feel the vibration, right? You can feel that something is moving inside and it is causing it is producing sound, isn't it? And what is that? Okay, there is one device which is there, or there is one part which is there in the body which is called larynx. What do we call it? A larynx, and locally it is called as voice box. What do we call it? A voice box. Okay, this voice box is able to produce sound. Now let us see how this voice box vibrate and it produces sound. So we learned that sound is produced when the vibration of voice box occur. Let us see in detail now. Okay, this voice box or larynx is located just at the upper end of the windpipe. Where the windpipe start, there you will find the larynx or the voice box. What is another name for the windpipe? We have learned about respiratory system, and there we have learned about windpipe. Yes, and another name for the windpipe is trachea. Okay, just above the trachea, where the trachea is about to begin, you will find the larynx or the voice box. That's the location of the voice box. Let us see how this larynx is producing or vibrating. Okay, the larynx or the voice box have two vocal cords. Okay, what are they? Two flap-like structures like this. Okay, look at this. This is one. Okay, this is one part, and that's the another part. Okay, these two parts which are there, these are called vocal cord. What we call them? A cord like structure, and therefore we call, because it produces sound, that's why we call it the vocal cord. Okay, this vocal cord, when air blows through this hole or passage, these two cords vibrate, and what happens when they vibrate? They produce sound. Okay, that is being produced. Sound is being produced. You can do the activity at home. You take a paper. Okay, take one paper and cut the paper into strip like this, and put one strip over the other. Okay, and you can seal the ends of the both the strips and try to blow air through this narrow gap which is there. What do you notice? These two strips will start vibrating and a particular kind of sound is being produced. Okay, same principle is being used, or same thing is happening in our body also. There are two flap-like structure, those are called vocal cord. When the air pass through the gaps which in between this vocal cord, what happens? these two vocal cords start vibrating, and that's how the sound is being produced in the human body. Understood this phenomena? You can try the activity after the class. This is very simple. You just need two paper strip, attach both the paper strip, keep the both paper strips should be of same size, and you seal the end with either sellotape or try to put a gum, or you try to put something so that the ends are sealed and you have a gap in between. When you blow air through that strips, you will notice both the strips are vibrating and it is producing sound. Same principle I have told you, it is being done in a human body, and that's how the sound is produced. So when the lung air force through these gaps, what happens when we try to speak? When we open the mouth, the air passes through the gaps which is there in between the two vocal cord. The vocal cord will start vibrating, and thus we are able to produce sound. Interesting, right? Very interesting part of the lesson that we have learned. We all this time we know that we are talking, we are communicating, but how today we have learned that how we are able to communicate with one another is because of vibration that is being produced inside the by our voice box. So what is present in the voice box which vibrate? Which part of the voice box or larynx is vibrating? Which part of the voice box vibrate? That's the vocal cord. So vocal cords vibrates and sound is being produced. Okay. So now you already understood this. So in this picture you will see there when the air forces in between. So the through those gaps air goes inside. The vocal cords vibrate. They open up, and the sound is being produced. So vocal cord open during the breathing. So when we breathe in, this gap is open. Vocal cords are open. When we breathe out, during that time the vocal cords are closed. Okay, and that's how the sound is being produced by opening and closing of this vocal cords. So now very interesting part comes here, that we know that a male voice is completely different than a female voice, isn't it? Till your 8th standard or till your 9th standard, most of the time boys and girls have the similar voice. But once your teenage start, once you start seeing the hormonal changes, physical changes, adolescent changes, during that time you will notice a boys will have slightly different voice than the girls. Okay, and why it is like that? There is an increase in the length of the vocal cord that take place during the adolescent period. Women have a very short vocal cord. What is the length of the vocal cord in women? 15 millimeter long. Okay, 15 millimeter means how many centimeter? 15 millimeter means how many centimeter? Can you tell me how much it will be? Whereas in men, a length of the vocal cord during the adolescent period, the vocal cords start increasing in males. Okay, and it increases up to 20 millimeter, or it becomes 20 millimeter. And therefore the length is different in male and female. Therefore the voice is also different in male and female. Now you know the reason why males have different voice than the female. It is all because of the length of the vocal cord. Okay, in vocal cord, in female and in children, the vocal cord is about 15 millimeter long. But during the adolescent period, the male vocal cords start increasing in length, and it may increase up to 20 millimeter long. And because the length is different, the quality of voice differ. Yes, and since I have told you 1.15 millimeter means 1.5 centimeter and 20 millimeter means 2 centimeter. Okay, that's the difference, and because of this 0.5 difference, you see the quality of voice differ in male and female. Now since we already understood how the sound is produced, let us now understand the propagation of sound. How the sound is propagating, how the sound is traveling. Propagation means how sound travel from one region to another region. Okay, as I already told you, what need for the sound to travel? Sound need medium. This medium can be what? It can be solid, it can be liquid, or it can be gas. So for the sound to travel from one place to another place, so traveling of the sound, we are going to call it as a propagation of the sound. And how this propagation of the sound take place, that it has to be something medium which will help us in propagating of this sound wave. Okay, either it will be solid, liquid, or gas. So the sound produced by vibrating object travel through the medium to the listener. Suppose that's a source of the sound. Okay, that's a source of the sound. So this one is producing a sound. This sound need to travel from this source to this listener. Okay, so how the sound is traveling, we know that sound travel in form of wave, and just now we have seen there are two types of wave, transverse wave and longitudinal, depending on the pattern that has been created by the vibrating molecule around the source. Okay, now the sounds, they are traveling from the source to the listener in form of this wave. There has to be something to carry this sound, and that's the medium which help us in propagation of sound. So let us understand the propagation of sound in more detail. As I have already told you, sound is said to be propagate when sound waves spread in all directions. So how sound wave propagate? How do sound wave propagate? In form of sound wave that produce in all directions. Suppose that's a source. Okay, that's a source which is producing the sound. So sound is traveling in form of waves in all direction. When the sound spread in form of wave in all direction, we hear the sound. Now how this sound is able to spread in all direction in form of this wave? There is something which helps us in carrying this traveling of this sound. The substances around the source of sound through which the sound wave spread is called a medium. So how do you define a medium of propagation? You may get question for exam, define medium of propagation, or what is medium of propagation of sound? The substance around a source of sound that help in spreading this sound wave is termed as medium. As I have told you, medium can be a solid, medium can be a liquid, medium can be a gas as well. So medium can be of three types. Okay, you can do this activity right now. One example in this animations, you can see when somebody knock a door, we hear that knock inside the house, isn't it? And because of that knock, we get that hint that someone has come to our house, that we have to open the door. That means when the person is banging the door or knocking the door, the sound is being produced over here. This sound has to travel from that door to inside. So that means from this solid object it is traveling. So this gives us indication, that hint that sound can travel through solid medium as well. Okay, you can do this activity right now. Wherever you are sitting, suppose you are sitting near a study table, or you are sitting near a sofa, you have a table there. Try to take your ear near the table, and from the downside of the table you just start scratching the table. What do you notice? Start doing this activity with me. When you take your ear near the table and when you are producing the sound beneath the table, what is happening? You are able to hear that sound little louder. Yes or no? So when you take your ear near the source of the sound, what do you notice? That you are able to hear the sound little louder. This gives clear indication that sound can travel from solid as well. We hear the sound of the firecrackers, bursting of the firecrackers. During the festival time, we burst firecrackers, and it, along with the beautiful light pattern that the firecracker create, we also hear the sound, isn't it? So this gives us clear indication that sound is traveling from the air medium as well. If the air was no air molecule, we would have not been able to hear the sound of this cracker. Okay, so I have told you to do the activity with the solid. Have you done the activity? Wherein I have told you to take the ear near the solid object and you hear the sound little louder. This gives us that sound can travel to solid as well. Sound can even travel to liquid. You can do the activity today at home. You have the chime. You must be having a chime at home. Okay, a small bell that we use during the puja. Okay, that's called a chime. Okay, you do have this at home. we can use that chime. You take a bucket full of water, okay, and you first take the chime and you strike it and produce the sound outside the bucket of water. You try to hear the sound, and then you take that same chime and you try to strike it inside the bucket of water, and then you see the difference. You can tell the difference later on during my next class, okay. But in both cases you will able to hear the sound. This gives us clear indication idea that sound can even travel in through the liquid medium as well, okay. And we know that air, I don't have to explain, I am talking here. If there was no air molecule around me, you would have not been able to hear my voice. So this is another indication that sound travel to air, and these are the three medium through which the sound can travel, okay. Solid, liquid and gases. If the sound was not traveling in liquid, then the aquatic organism would have been not able to communicate with one another. Because the sound is traveling in liquid as well, they are able to communicate with one another by producing some kind of sound, okay. So as I already told you, gas molecules, what happens in the air? So when you are speaking, the air molecule around you, they also start vibrating, and we know that vibration is passed on from one molecule to the next one, so from next molecule to the other one, and we are able to hear the sound. Okay, now let me give you one example. Suppose we have, you know, the location of your school. So now, suppose now after the end of the first period, bell is being rung in the school by the peon to indicate that's the end of the first period. You can hear that sound of the bell in the classroom. Now this sound of the school bell you will hear up to certain distance, right? After certain distance, are you able to hear that sound which is being produced by the school bell? Can you hear that sound sound that is being generated by the school bell after certain distance? There has to be limit. After certain distance you are not able to hear. So what is happening? The sound, as the vibration is passing from the source to as it is moving in form of wave, the waves become smaller and smaller and smaller, and finally it travel like this. And that's the time you may not able to hear that sound at all. So here what happened, as the one molecule passing the energy to the next molecule, the energy is getting decreased and decreased, and the sound is becoming fainter and fainter, okay. So there are some characteristics of sound wave that are you going to learn in the next part of the lesson, okay. Before that, let us give one activity for you, okay. What you can do, which is very difficult to create a vacuum, okay. But if there is a vacuum, and if there is there's a vacuum they have generated, they have used a suction pump to suck the air out of this belch, okay, and there is no air. So as there is no air, that means the complete vacuum, no medium at all, you cannot hear the sound in a vacuum. To create a perfect vacuum is little difficult at home, but you can, I will send you one video link. In the video link you can able to try to watch the video, and you will able to see how in the vacuum the sound is not being traveled, okay. So this activity gives us clear indication that sound needs something to travel. If there is nothing, no air molecule, sound is not going to propagate. So sound cannot propagate in absence of medium. That means in case of vacuum where there is no air molecule, if you try to remove all the air, then the sound do not travel in vacuum. That's thing what we have learned in the previous lesson. What we have learned just now, that sound need medium to propagate. For the propagation, for the traveling of the sound wave, medium is very, very essential. Okay, that's the reason astronaut cannot talk in the outer space, because there is no air in the outer space, and therefore what do you notice? Because there is no air in the outer space, astronaut whenever they are communicating, their sound cannot be heard by the next person. So there is special devices that they use for communication, okay. That's not the part that we are learning. That's a small little example that I have given you, that sound require medium to travel, okay. Sound propagate more clearly in solid. So the decrease order, so solid comes first, then comes the liquid, okay, then the least in air. So in case of solid, what is the speed of the sound? It is very high. See, these are aluminium, steel, iron, these are different solid object. So in case of solid object, you see that speed of the sound is 6420 meter per second. Then steel is 5960. So the speed is more in solid. As you can see, in liquid, in seawater and distilled water, it is getting decreased 1530. And as you can see, in the gas, the more speed is getting decreased and decreased. So in case of hydrogen, it is speed is 1284, whereas in case of oxygen it is 316. So this gives us clear indication and idea that sound, okay, sound speed is decreasing. From solid it is more, then followed with liquid, and least in case of air. Okay, so let us now understand the characteristics of sound wave. Okay, these characteristics we are going to learn in more detail in our next class. Okay, now right now let us just see that there are some characteristics, certain things which we are going to learn about the sound wave in our next class. Before that, let us now summarize what we have learned in our today's class. What we have learned? We have learned about sound. What is sound? Then we have learned how the sound is produced. What is the cause of sound? Okay, what is the cause of sound? Then we have learned about propagation of sound, how the sound propagate from one place to another. Okay, under the cause of sound, we have seen how the sound is produced by the human voice box, and we have also seen what sound travel in form of wave, and this wave can be of two types, transverse wave and longitudinal wave. In our next session, we are going to learn about what are the characteristics of this sound wave, and we are going to learn about the working of human ear in detail, how our human ear works. Okay, so today's class we have finished the part 1 of the chapter till propagation. I hope you have understood. If you are watching my videos for the first time on the YouTube, you please subscribe my channel. You kindly hit on the like button. Also hit on the bell icon so that you are going to get notification about the latest videos in the coming days. Okay students, thank you very much.